All right. Welcome back. We are GDD403. That's problem solving with data structures and algorithms in the winter 2023 semester at Canadore. And it's week 3, part 3 of our broadcast and recording. I don't think we're going to make another part for this one. Let's see how it goes. We have about an hour left, and we have to do everything in about an hour, including a little bit of lecture and some lab work in class exercise time. All right, let's talk about this. So what I want to do now is talk about the lecture piece. But before I get to that, I want to mention 2 more things about using Git and GitHub online. And one of them is, what if you just didn't want to do any of that command prompt stuff ever? You don't like that kind of stuff. It's not your thing. It's not your bag. I don't know what you want to call it, right? I just don't want to do that, right? Is there another way you can do it? And there's certainly some great tools out there. And I'll talk about, kind of like the tools that are out there that are popular. One of them is GitHub Desktop. So if you go desktop.github.com, you can certainly download a UI that does something very similar. It's a no-frills, kind of way of downloading and installing, kind of Git, making it work without command prompts for the most part. Okay. One thing that it does really well is it kind of, kind of abstracts away kind of those commands. You don't have to worry about them, and it does it all for you. This is one way of doing it. Again, I think it's important for us to have gone through that whole process so you understand this, but this is not a bad little tool, free to download, no problems. Other one that you can use is something called Source Tree. Source Tree. Source Tree is a great little tool. Again, it's visual. It tells you, you can see here the branch, the development branches in different colors. And again, you can do commits and pulls and pushes and merges and all that kind of stuff. And sometimes I'd like to use a command like this, a command tool, a UI tool like this, when it comes to merging, because merging can be so, you need to visually see what's going on, without it. And it's great because, again, it's Mac and Windows compatible. It's pretty good. Maybe a higher level tool that I like a lot that you can also get for free is Gitkraken. And Gitkraken is a bit more visual than everything else. So if you really like visual tools, Gitkraken might be for you. And the great thing about Gitkraken is it's also part of the free GitHub for Education pack. GitHub for Education pack, which you may not know about. And it may be the same thing with Canadore College, by the way, when it comes to they not recognized or whatever. But let's go there and look at that. If I look at GitHub for Education, here's my GitHub Education pack. It comes with a bunch of stuff that you can use. So here, this is the pack itself. I'm going to give you this link. So this link here is an amazing link. It gives you incredible little tools and stuff for free. Okay, let's go through some of the stuff that it gives you. Right. So if you look down here, there's your JetBrains tools that you get. You get Heroku a bit for free, Microsoft Azure, Namecheap, and DigitalOcean. There's your GitHub, Pro Tools, Code Spaces, which is something new in GitHub, which is kind of neat. GitHub Pages, when you want to publish your stuff live. We're going to do some of that this semester as well. Visual Studio, which the different essentials there. GitLens, which is an extension for Visual Studio Code. MongoDB, and it just goes on. And this is the one I'm looking for, the GitHub Gitkraken Client Pro, right? Which is a $59 value, and you can use it as long as you're a student, which is pretty awesome. I can't stress enough how awesome this thing is, this developer pack. And for complete free for students, it just keeps going. There's just more and more and more and more, and holy cow, there's so much stuff here that you can get for free. Okay. And a lot of it's already free. Sometimes it just needs a bit of they also advertise some really cool tools here, which is good. If you've never heard of them, there's some great tools here that you can use. All right, so please, I encourage you guys to get this thing. All right, so if you get that, then Gitkraken Pro becomes something that you can use. And again, if you're choosing not to use command prompt, then this is amazing. And it also includes GitLens, which is also awesome by these same people, right? So really amazing thing. Take a look at this. If you're going to use a UI, Gitkraken or GitHub Desktop or Source Tree or other ones. Okay. Right. So that I just wanted to finish off that Git discussion with these things, and let's move into the topic of the day. Any questions around anything like this? People have always asked me when we do these kind of talks with me and students. They said, like, do you really care? If you're going to ask me, do I really do you really care about how we do it? And the answer is not really. I mean, it's like, I'm not going to, put you in a box and tell you must do it this way. There's more than one way of doing everything that we do, right? But do I recommend learning command prompt? Absolutely. It's a marketable skill. Anyone can use a UI. Not everyone can do command prompt. And that means that we're going to practice it. I'm going to be using command prompt with you from now and for the end of to the end of the course. But if you feel it's challenging sometimes and you get stuck, use a tool. Okay, that's also an option, and it won't matter to me. As long as I have my requirements met, I'm good. So far we've been talking about Git and GitHub, and what I want to talk about is the next part of our course, the real stuff. I'll do a short lecture, quick, talk about some concepts, and we'll get right into it with Unity and make a base project for us for today. So again, we want to talk about is, what is an algorithm? What is a data structure? Those kind of basic things. Let's do that. So what is an algorithm? It's a bunch of code. That's what it is, right? And it's a code that we want to use to solve a problem, right? That's what we want to do it for. That's the main thing. It's code used to solve a problem. And then what is a data structure? Some kind of storage container. A storage container that is that's some way of organizing our data, whether it's an array, a list, stack, queue, whatever, some kind of organizational structure. Some of them are built into our language, C# and C++. They have that built in. Some data structures we need to create. Trees, as an example. We're probably going to have to create trees and linked lists and other things by hand. They have linked lists, but we're going to probably do a lot of it by hand. All right. So that's what a data structure is. Bonus, what is a design pattern? A design pattern is a repeatable solution that we can use to solve problems. And I want to talk about design patterns really briefly. I talked about them kind of, at the break with some of you. And if I looked up programming design patterns, if I looked that up, one thing that you want to look at is, object-oriented design patterns. There is a book that came out. So if I look at object-oriented design patterns, here it is. The book that was originally published back in the 90s, 94, and you can find kind of a little bit of a brief on it on Wikipedia. It was done by the Gang of Four, and it was done by Eric Gamma, Richard Helm, Ralph Johnson, and John Lycides, right? Those four pioneers of object-oriented programming and design, they kind of noted that there's a lot of repetition when it came to the way we do our design patterns when we're actually coding, right? We see a lot of same things over and over again, and they're like, isn't there a way of documenting these things, best practices that we can pass on to our colleagues in the software engineering industry, and so that we can have, easier times when we're programming, for our clients, right? Or for the corporation that we work for. And they came up with 3 different kinds of design patterns, 3 categories. And one of them is creational, another one is structural, and another one is behavioral. So creational, we've mentioned this before earlier, singletons are very popular to use. It's like a static instance that we're going to have access to. Factory method pattern is something that we're going to learn this semester as well. So singleton, factory method pattern, and then as well as some other ones here is like that we're gonna kind of hit. One that we might kind of also look at is the state pattern, and there's other patterns that have been derived from these 23 design patterns. So challenge for you guys at Canador, right? Learn as many of these 23 design patterns as you can before you leave school, right? And this way you have a nice bunch of tools in your toolbox to solve some problems, design patterns, kind of programming problems. There is a great little book that I recommend to you, which is Game Programming Patterns, Game Programming Patterns. And the Game Programming Patterns book is a free book that you can download, and please put this in your arsenal of knowledge that you're going to have for you. This is the one. Okay, I'm going to give you the link here. I'm also going to put the link just because we're talking about it. It's so critical, again, that I think you guys should have this thing, that it should be inside of your course shell. So I'm just going to put that in there as well as a link. And I should have probably put that in there earlier, but this is game programming patterns. Let's take a look at some of those. So game programming patterns, pretty awesome. And let me talk about them. It talks about all the 23 design patterns plus others that have been derived from them that are 100% related to the game industry. Okay, so this is what you need to know as a game programmer. If you could learn some of these, right, especially the ones I mentioned, we're going to be handling something called the object pool design pattern at some point later in the semester. And again, it talks about things like, you know, why do we do it? You know, what's the problem? You know, it talks about the problem and how do we solve the problem? What's the pattern? And it even gives you a little bit of code, some pseudocode, a lot of times to kind of understand how to solve that problem. These design patterns is something that we're going to link into or hook into our data structures and algorithms conversations, right? Because it's not enough to know how to make a, you know, data structure. The question is that I always get from students, well, you know, sir, I've learned how to make an if statement and I know how to do a for loop and I know how to make a basic project, but I don't know how to make a game. I don't know where to start, right? And it's hard. It's not because they're wrong. They're absolutely right. You know, you need to have an idea of how to kind of create your own code. And I think this is a great starting place to look. If I had a problem, and some of these might solve my issue, all right? Especially when you get very complex code bases later on, like, you know, in terms of millions of lines of code. Okay, so let's get you know, kind of move away from this. I just wanted to point it out as a bonus because you're going to be using these design patterns throughout. So what is a design pattern? We also need to talk about big O notation because big O notation is something that all of you need to learn. So again, a foundational piece of knowledge. I learned about it, you know, way back in the day, and you need to know about it as a software engineer at the very basic level. Really what it is a measure of the time versus memory or space consumption that your algorithm is going to use, right? It's a measure of performance. And back in the day, we used, you know, performance measures to measure every piece of my code so I can improve its performance, optimize its performance, right? And big O notation talks about the worst case scenario for a particular piece of code. What's the worst case? How long is it going to take to do stuff? Let's talk a little bit about what all these things mean. And the way we look at it is if you have an O here and an example, and you have O of n, notice I said of, brackets, O of n squared, you know, as an example. And this means that the algorithm is, you know, kind of, it's in, you know, kind of quadratic. And it's using quadratic time. And it's pretty bad. Typically, if it's quadratic time like this, it means that every time we have an input, one input will be okay. But if we have two inputs, that means it's going to take a factor of four times longer. If I have three inputs, it's going to take 9 times. It's going to do something 9 times as much, and so on. And so what's going to happen is, or 9 times the space, 9 times the memory requirements for 3 inputs, quadratic time. Okay, and usually it's pretty bad. So let's talk about different kinds of common runtime functions. This is the best, constant time, O of 1. Okay, again, could we make all of our functions that we're going to write be O of 1? Chances not. All right. Why? Because it covers usually very simple things. I want to assign a value to a variable, O of 1. Okay, very simple. I want to find if a number is even or odd, O of 1. I want to find a value on a map, O of 1. Okay, that is what it is. Check if an item is in an array or is null, O of 1. Okay, so that's what it is. Pretty simple. Here's the next one, O of log n, right? So this is logarithmic time. Logarithmic time basically is actually better than O of 1. It's actually a better thing to look at. We'll look at the map later on. So again, here's logarithmic time. Finding the index of an element in a sorted array. If it's already pre-sorted, then I can find that index pretty quick. O of log n. Okay, so really good. Find good performance. These are all good performance. Okay, that we're talking about. Okay. O of n. linear time. Okay, the function O of n grows more quickly than O of log n, right? And square root of n, there's another one. Square root of n is, again, not as much popular. However, I have to mention, if you use square root in any of your stuff, for example, I want to find the distance between two vectors, and I'm going to use a square root function to find the distance between two vectors in every frame. Guys, that's terrible. Avoid using square root in anything that you do, all right, ever, as much as possible. And especially when it comes to distance calculations, collision detection, all those kind of things, bad, okay, in terms of performance. So again, so algorithms of O to the n or O of n, linear time, not so bad, right? But not as good as O of log n, because that's logarithmic. That's actually lower than O of n. O of n is like linear. It's like 1-to-1. X is equal to y when it comes to stuff that you're going to, for every input, there's an output, all right? You know, so things like simple looping structures. If I do a for loop, O of n, okay? If I have one for loop, if I loop through something, like looping through a list of values, O of n, not bad. Okay, still not bad. It's not, it's still in the green part of our performance, okay? O of n log n, okay? So again, you know, I got a nested loop structure. Okay, so now this is a little worse, okay? A nested loop structure. And or I'm using some kind of efficient sorting algorithm, like a merge sort or a quick sort. We're going to talk about merge sorts and quick sorts later on, okay? Then it's O of n log n, okay? O of n squared, we just talked about that, quadratic time, bad. Okay, this is where we start getting bad, right? An algorithm that loops over all of its inputs, and then for each of input loops over the inputs again, that's like really bad. So again, a nested loop within a nested loop that's not sorted, using a really inefficient, any kind of sorting algorithm, a lot of times is this bubble sort, insertion sort, selection sort, all of those types of you know, algorithms that we're going to be creating later on. You're going to notice that they're of O, they're quadratic time, you know, O of n squared. Find all possible order pairs in an array. Right, I got to loop through both sides of the array to do it. I got to loop twice. Quadratic time, bad. Okay, that's how we're getting bad now, right? Worse, okay, O of 2 to the n, exponential time, right? So this is where things grow exponentially, right? So again, some kind of Fibonacci sequence, right? Anyone remember the Fibonacci sequence from math? Maybe if you guys did that. Things like where you add the number to itself to the previous number and to get the next number. So again, example would be something like, if I start off at 1, the Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, and so on. It kind of grows that way. A Fibonacci sequence and calculating the next Fibonacci number, exponential time. It's tough to do it, right? The traveling salesman problem using dynamic programming, right? It's okay, Scott. We're going to kind of cover all these things, you know, this kind of thing. The traveling salesman problem using dynamic programming is huge. Okay, it's a very, I would say, a classic problem that we talk about, and we're going to talk about it in this course. The knapsack problem, another common thing that we're going to talk about. It's another thing where you hold stuff in your knapsack and you have an inventory system, pretty much. Exponential time, okay, in terms of keeping track of stuff. All right, and that's bad. Worse than that, factorial time. All right, so remember, a factorial is n factorial is defined for integers greater than 0, and where we want to find, you know, example, if I say a factorial of 2, you know, as an example, then it's like 1 times 2, you know, and as an example, 3, factorial of 3 is 1 times 2 times 3, and then, you know, you can kind of have a factorial of whatever that factorial is, factorial of n, or whatever, and that factorial time is bad. String permutations, solving the traveling salesman problem with brute force search, a really bad searching method, that is O of n factorial. Okay, this is bad, right? And it's really bad because it becomes worse and worse in terms of time and space considerations. Okay, we don't want those kind of things. If we're going to look at this in a graph, it's going to look like this. Okay, so this is kind of an important consideration. Notice that O of 1, right, is the best because it's linear. Or it's not even linear, it's the same every single time. O of 1 doesn't change. Doesn't matter what we throw at it, it's just the same. It takes the same amount of time, right? O of log n is pretty damn close. That's what we wanted. We want O of log n, kind of algorithm as much as possible. O of n, right, which is kind of linear. It's okay. It's not bad, but there's something we can do in between maybe to make it better, right? O of n log n, still not so bad, right? Kind of like, again, O of n is like a for loop. O of n log n, maybe a double for loop. That's okay. But once we get into these things, you can see how bad they become. Like I'm talking really bad. So this is the number of, seconds elapsed and how much, continuous, like it just rockets in terms of memory. If this is memory on the left or space on the left, and this is seconds on the right, you can see that in a very short time, the amount of memory or space required goes way up, right? And that is these are bad algorithms, okay? One thing we can always look at, and I shared this with you, is this cheat sheet, and it does the exact same graph, but it also provides some, kind of a measurement. That's what these things are. These are performance measurements of each of the different kinds of data structures that we have here, and different kinds of algorithms. So, for example, a data structure like a stack, it's O of n, right, which is not terrible. An array, though, right, when it comes to access, this is accessing an array, is O of 1. Accessing, that's why arrays, a lot of people, when they talk to you and say, I'd rather use an array, right? And the reason why they want to use an array a lot of times is because it's quicker, system-wise, than a list. A list is easier to use, an array is faster, right? So at least accessing an array, access time. Searching an array, O of n, all right? Same as a list, right? But, once we get into insertion, O of n, not bad, right? Other things are much better when it comes to insertion. For example, insertion and deletion, right? Then a queue or a stack might be a good solution, which we're going to talk about what those two things are, right? And you can see that this is average and this is worst case scenario. These are different scenarios that we have here, right? Worst, right? And this is time complexity, and there's also space complexity. Space complexity here, you can see that all of these are the same. They take up the same amount of space. That means memory, okay? But time complexity is what we're really looking for. Performance, CPU performance, GPU performance, okay? Especially for game dev. And different things here. Notice that when we see B tree, this is a binary tree, binary search tree, or B trees, right? You can see that it's O of log n, so it's better than O of n, right? Better. It's actually a better, look at that, green algorithm, right? Better than O of n, but not as good as O of 1, okay? So O of 1 is like rare, right? We don't get that a lot, okay? And then there's bad stuff. You can see some bad stuff here. Sorting and searching algorithms you're going to see are really inefficient. One thing to always think about is pre-sort a list as much as possible before. Don't do it in real time, right? Do it off screen. Do somewhere else, right? Pre-sort everything ahead of time. Pre-sort all that you can, all right? Because if you can do it offline, you don't want to do it in kind of at the time of. If you have to sort something like in real time, look, any kind of sort, pretty much, right? Unless you're doing something like a counting sort or something, even these quick sorts, right? Quick sorts are not bad. Time sorts and heap sorts and bubble sorts and all that stuff for best time complexity is not so terrible. But you can see things like the selection sort, pretty much we should never use, right? So we can tell you where it's really bad. Shell sort, really, really bad, right? But there's some other ones that are pretty good. Merge sort, quick sort, that's really good thing. In terms of space complexity, worst case scenario, the quick sort is a big, memory hog, right? Whereas you can see merge sort, time sort, and heap sort are pretty good, right? In terms, remember O of n log n, it's orange, which means it's in here, right? And it's not as good as yellow, and definitely not as good as this light green color. This light green color is what we really want as much as possible, okay? So wanted to share this with you because you may have not known about it, and we're going to start measuring our performance after this, as we go forward, okay? All right, so that is our little cheat sheet. Questions around big O notation, all right? As a general rule, if you're going to make a formula, if you're calculating a formula and it has some kind of square in it, n squared, a squared, b squared, c squared, it's quadratic time if you're going to figure it out, okay? And if you're doing a formula, if you're calculating a formula and it has square root, ooh, it's really bad, right? And again, going back to that thing, square root time, I mean, you're talking about like way up here, right? Like, you know, something like in this area right here, horrible, where it says performance-wise, okay? And the reason for it is because any kind of square root or to the power of operations, look, power of or square root is in here. Okay, that's what we're talking about, horrible. So imagine I'm doing distance calculations. I want to do a collision detection between two circle colliders, and they're coming closer, and I'm calculating the distance between centers all the time, every frame. Bad, really bad. So how we go around that? Because we still need to do distance calculation, even things like with raycasting, we want to do the distance calculations, right? We can do something called squared distance. It's not as bad as square root, which is probably in there, but still pretty bad. All right, so it's never going to be ON log N. Okay, it's not going to be like that. Okay, it's going to be in there, in this horrible area. So remember, thinking about things like raycasting, the reason why NVIDIA developed their own chipset and have thousands of cores in their GPU where they offload things like raycasting in there is because it's horribly bad. So they can have all those GPUs work on that problem all at once. And that's why raycasting RLSS is super computationally expensive. For a regular CPU like ours, I mean, how many cores do you have? 15, 20? How many cores do you have on your CPU, right? But an NVIDIA, you know, any kind of dedicated GPU, a discrete GPU's got, you know, thousands, 3,000, you know, something like that. And they use all of those cores to crunch a problem. Same reason why when we do AI, a lot of times they use the GPU. We offload the job to the GPU because it does all those things. You know, it can work a lot more because it can do parallel processing and kind of break that problem down and use the, you know, all the GPU to do even better. All right, so that's what we talked about there in terms of big O notation and performance. Let's talk about collections and generics a little bit. Now, again, you guys know about collections and generics, right? But that's why I'm going so quickly through this stuff. So anything that you've already touched upon, potentially, I'm just going by. Big O notation, I slow down a little bit. But here, you should know about CRUD. Create, read, update, and delete. And a collection is basically some kind of data container that allows me to use these CRUD functions, create, read, update, and delete. You know, when it comes to objects that I'm going to store in the container. And when I say objects, either it's a object that is a system object, right? So some kind of primitive, an integer, a float, double, whatever, one of those, or a complex object like a string or some kind of array. Okay, so whatever that's going to be, I can store that thing inside of my data structure. I can store a data structure in the data structure if I want to, a collection within a collection. Typically, collections are broken down into two parts, linear and nonlinear. And when we think about linear collections, we think about things like, you know, lists, you know, arrays, stacks, queues, and all that kind of stuff. Those are all linear collections, okay? And some rules to know or to remember about stacks is stacks use something called a, you know, kind of a last in, first out kind of methodology. Think about stacks like, and we'll talk about this again when we get to stacks and queues. Stacks are like stacks of plates or a stack of cards. The top card is the one that you're going to pop off the stack. The top plate is the one you're going to take to, you know, for your lunch, you know, whatever it's going to be, right? Typically, we don't take the bottom of the stack. We don't do that. We take the top of the stack. So it's last in, first out kind of access. Queues are the other way around. It's first in, first out, or first come, first serve. Think about a queue like a lineup, right? If you're driving a car, you're in a queue, a line, and you're waiting for the light to turn green. You know, as an example, if you're in a restaurant, it's self-serve, you're waiting in line to get your in a all-you-can-eat restaurant. You might go and just pile stuff on, but you got to wait in line for you to do that. Or if you're at an ATM, you might have to wait in line. That's a queue. Lineups, right? And it's a sequential or linear collection. And usually all of these collections have similar or the same objects that are stored within them, okay? Arrays, queues, stacks, lists. Nonlinear collections, all right? Trees are a good example of nonlinear collections. Heaps, graphs, networks, all those kind of things. They're nonlinear collections. And we're going to learn more about trees, especially binary trees, which are really should be near and dear to your heart as a game programmer. Without a binary tree, it's hard to do decisions and it's hard to do other things. Binary trees are amazing for all kinds of things. And there's also other non-binary types of trees, especially for behavior trees. Behavior trees might have multiple children for each root. So here you only have a root and 2 children. And each child can also be a parent node to other children. Okay, that's how it kind of works. And you have different levels, 0, 1, 2, 3 in this case, right? This is nonlinear collection type. It stores the same type of data again throughout the entire structure. And one thing we have to talk about is almost all collections have some things in common. They have some kind of way of counting the collection size. So whether it's called size or count, that's what it is, or length, one of those 3 things. And they also have an add, an insert, or remove, some kind of functions that allow me to clear or check to see if an object has an item, the collection has an item, or the index of a particular item in the list or a collection. Okay, those are all very common methods that we're going to be dealing with this entire semester. Okay, that's how we're going to do it. And, we can categorize collections as 2 types, right? Linear collections are either direct access or sequential. Those are the 2. And nonlinear collections can be either hierarchical or grouped. Okay, so those are some things we have to know as well. All right. So let's talk about direct access collections. Array is a good example of a direct access collection where you're directly accessing the members of the array with some kind of zero-based index in C# and in C++. And all C-influenced language, we use something called zero-based counting, all right, which is we start with the 0th member and go up from there. You guys know all about that. Next. And again, efficiency-wise, adding a new element to the array is efficient. So again, think about this as probably O of n, right? Or O of log n, right? So something like that in terms of adding new members. Inserting, not as efficient because we have to insert it. We have to move things around. Once I start moving things around, now we're going into quadratic time. Okay, once we're doing that kind of stuff, it's that bad. When I have to do sorting and searching or inserting or deleting, quadratic time, right? And deleting the end of the array, it's the last element, or the front of the array, the first element, no problem. We can totally do that. But if I do the first element and I have to rebalance the entire array, it's probably at least O to the n, at least, right? When it comes to that, deleting a specific element and then rebalancing the entire array, again, very inefficient, probably quadratic time. Okay, for that thing. And in terms of other things to note, we have other direct access types, which are the struct types. Now, without looking forward, what is the difference between a struct in C# and a struct in C++? Do you know? Anybody? There's a difference. In C++, let's talk about a struct in C++. A struct in C++ is almost identical to a class in C++, right? Structs and classes, they all have methods. They can be inherited from in C++, no problem. The difference is access. C++, the class, the struct is a public. It's all public by default. And a class is private by default. So classes are private, structs are public, and that's it. That's the difference in C#, in C++. In C#, very different. A class is a reference type, and a struct is a value type. A class, as an example, is private by default in C#, and public by default. The struct is public. A class, is very different in terms of you can inherit from a class in C#. Struct, you cannot. Okay, so there's like things that you can do and you can't do with structs. Why would we use them? Because they're quick ways of creating our own custom data type that do not require getters and setters. We don't need those things. You could add them, but you don't need them, right? And a good example of that is the transform. Or if I make a transform and I want to use position, rotation, and scale, right? Do I want to use get transform, get position, get rotation, get scale? No, I want to directly access those things. Now in C#, they've done it in Unity where you can actually you only have read access. So they actually have properties. They actually have getters and setters, but it's kind of like a struct. All right, so again, C# is really cool because it's again, it's a value type. Value types need to be copied, and there's some stuff more about structs that I put in here for you. They're value types. They're copied, where they're not reference types like classes. Classes are like I can point to a class object. For a C# for a struct, I got to copy the object over. If I pass it into as a parameter, if I pass a struct as a parameter to a function, I'm actually making a copy, right? Where if I pass a reference to a class as a class object in a function, I'm pointing to it. It's a pointer. It's a reference, right? So in many ways, classes are more efficient when it comes to referencing them. But if I'm going to create something, a little custom data type for myself, structs are the way I might go. Okay. So that is direct access. Sequential access collections are things like queues and stacks and linear lists, linked lists, those kind of things. Those are sequential access collections where they have to go from one, kind of element to the next element, one member to the next member. They're linked together in some kind of sequence. Okay, that's what those are. Okay, hierarchical collections. Okay, there's two types, right? There's nonlinear hierarchical and group collections. Hierarchical means there's a hierarchy, almost like a reporting structure, right? A good example is a tree. A tree is a hierarchical collection where you have the root of the tree and one or more children, okay, until you get the leaf nodes at the bottom. Again, we'll talk more about trees in later lecture. Group collections. Again, we don't use these as often, but for us as game programmers, we do. Sets are a good example. Graphs are another type, and networks are all types of group collections. Okay. Further than that, we can see what a graph might look like. A graph is kind of a bunch of nodes that are linked together, right? A good example of that is this map, where we can send a traveling salesman around. We'll talk about the traveling salesman problem, right? And the difference between a graph and a network is a graph might have weights, right? As an example. And so might a network, and the weights might determine which is the fastest way to get to a specific location based on the weights distances, as an example, between nodes. Okay, so that is the differences between different kinds of group collections. One thing that we're going to be doing, and maybe we may not do it this time, is a timing test. And timing test is what we want to start doing is going up online, and then creating a class like this, which we may kind of elect to do. And then in the timing class, we can use that class to kind of time how long it takes to do to do this kind of algorithm. We'll start the time counting, and then we'll stop the time counting, and then we'll get a measure of how long it takes for us to do that particular thing, whether it's sorting, searching, whatever it's going to be. And it's really efficient to do this because if our counting equates to a lot more, then maybe there's a better way to do it. Maybe we can improve our algorithm. We don't know if the algorithm is improved if that number of milliseconds doesn't go down. We want to be able to kind of measure how long it actually takes from an optimization perspective. All right, so this is the stuff that we want to do. And now, my friends, I'm hoping that you've installed Unity 2022.2.1F1, because this is the actual in-class exercise I want you to do. We want to make a brand new repository first online. Let's do it together. So online first, this is our in-class exercise now. Okay, I want to go up here, and on my my account, your account, someone's at the door.
Someone is at the front door.
We're going to make a new repository, right? And the new repository is going to be a master repository that we're going to put all of our in-class exercises in together, okay? But not our assignments. Assignments going to be something else, okay? So what I want you to do is, let's go up to GitHub and make a brand new repository, and we're going to call this, again, GDD403 in the winter 2023 semester, and you're going to call it ICES, right? Which means all of your in-class exercises are going to go here, right? It's almost like I want a containing folder for all my in-class exercises. And this way, you don't have to send me you don't have to request me as a collaborator multiple times. One time is good enough. The test was just a test. This is the real thing now. Here we go. So I'm going to go public for me. You're going to leave it as private, right? And then with your public private repository, you're going to include me again as a collaborator. Please do this now. So that's one step that you're going to see on your lab report that I'm going to update later on today. Okay. Create my repository. When I do this, I'm going to have a empty repository here that's waiting for me to make my files, right? What I'm going to do for you guys is when I work with you, I'm going to go into my desktop. I find that that's the easiest place to find stuff. And I have Canador, and inside there, I'm going to make my new repository, my new folder, and it's going to match the name of my repository. So if my repository is called GDD Winter 2023 ICES, then so too will be my local folder name. I'm going to make a brand new folder here, new folder, and we'll call this the same thing. So we'll say, you know, GDD403 Winter 2023, and then ICES. So I know that this is where I'm going to put all of my in-class exercises. Okay. We're definitely going to use a Unity gitignore, but not right now. Okay. In fact, I'm going to get you to add it now later. I'm going to give it to you. So if I go Unity gitignore file, right, there is a link that you can access. This is just one link that I found that is a common gitignore project. Here's the link right here that you can use for Unity. Okay, so what you can do is if I go to gitignore, right, you can see that there are a lot of different gitignores, right? So this is GitHub gitignore is what this is, right? And we want the Unity gitignore. So one thing to do is, you know, as an example, I want to grab this file and I want to use this as my standard setup. This is what we're going to do. So please hold on. We're going to use this gitignore file going forward. So hold on to this. Next, let's make a brand new Unity project. This is your in-class exercise. So I'm going to go back to Unity Hub. Okay, is my Unity Hub. And for us, we're going to do 3D. We're going to be working in 3D the entire time, right? So and this is why I asked you about Blender and all that stuff. I'm going to go into new project, right? And in Unity Hub, I'm going to select my version that I asked you to download, which is 2022.2.1F1. That's the version of Unity that I want you to use. I'm going to use a 3D core project. We may change that to URP later, but for now, I'm just going to use a 3D core, right? And I'm going to rename my project so it matches with your in-class exercise. So it's going to be, again, GDD403 and the winter 2023 semester. And this is ICE 1. Makes sense? ICE 1. I'm going to take this project and I'm going to populate it inside of that special spot, which is going to be on desktop. I'm going to go to Canador inside of my GDD403 W2023 ICES and put it inside of there. Select.
Here's what I found.
Yes. So this is where it's going to go. It's going to go inside of that special spot. And then I'm going to do create project. Okay, so that's what it's going to be. So again, I named the project like this, GDD403 W2023 ICE1. And then I put it inside that spot, inside of that folder, the master folder that's going to hold all of my in-class exercises. And then I'm going to click create project. It's going to take some time. Unity, regardless of what kind of system you have, is going to take time for it to do it. What it's doing here, and I'm talking while it's doing, so eating up some of your time here. And I know we're timing out here. I'm going to keep going. Hopefully you guys can stick around so I can finish this piece with me. If you can't, I'm just going to keep recording. I know I ran over time, but I wanted to get to know you guys a little bit. So, so Unity 2022.2 is what it's doing is it's generating the library folder. Guys, we don't want to put the library folder ever up to GitHub. Never, right? It's too big. I'd rather just download the simple project. And then what I'm going to do is I'm going to regenerate the library folder for the first time locally. And then I never have to do it again, right? But that library folder that I'm going to put up, that just takes time and there's no need for it. Okay, so that's why we're going to need a gitignore file after we do this. Notice I haven't made a GitHub or a Git repository yet locally. I've just made my container that's waiting for me up on GitHub, right? And I'm doing this because I want to prepare everything, you know, so I can put things up online. Okay. So remember, I'm going to put my gitignore file in. You know, again, there's a couple strategies. I'm going to put it in each of my projects, and there's a reason for this. This is why if I download the individual project, I got a gitignore file. It's okay to have multiple gitignore files, one for every folder. It's okay for that. You can also make a gitignore file that's for your entire master repository, but it's okay. Okay. So I'm just waiting for this to complete. As it's doing everything that it's got to do, we're going to make a very simple, kind of application here. All right. So here's my application, and notice that this is the way I set up. And I want to talk about this. This is my, I don't know, call it Tom's Pro layout. Okay. I don't prefer this one. I think this is a crappy layout. Okay. And the reason why I think that that's the way it is because it takes up a hell of a lot of screen real estate. I don't want this. Okay. And it also doesn't make any sense when I have something in the hierarchy here and I got to go all the way to the inspector over there. Doesn't make any sense. I also don't need to see this many assets down here. It's again, there's too many. So I like to see more space here for my editor and for the game. So what I do is I start with my new layout, and this is what I recommend to you for Unity. Go here where it says default on the bottom, on the top right, and then choose tall as a layout standard, right? Like as a base, if you will. There's my tall layout. And what we're going to do here in Unity is I'm going to slide this to the left. So I'm going to see it kind of look like a list, right? And then what I'm missing here is a console, right? So I can go to Window. I'm going to go to General, and I'm going to go to Console. And I'm going to take this console window and put it to the bottom, right? So this is kind of how it's going to work. So this is my preferred layout, like this. And I've named this something like Tom's 3D layout. Okay, so if I click on there, it'll always get me there, Tom's 3D layout. Even if I go to my default layout, if you gave me this, I would just switch to Tom's 3D layout because I just like this, working like this more. Okay. The other thing I want to do here, and this is our example for GitHub, is I want to change a couple things here. So my scenes, I always want to name my scenes with square brackets like this, scenes. And square brackets or an underscore or something like that is going to populate my scenes higher up alphabetically than anything else. Scenes. And the other thing I like a lot, I'm going to add a new folder here called scripts, right? So scenes and scripts, I always put them in brackets like this because those are important folders that I want to access all the time. Notice that scripts right now is empty. And remember I said GitHub, it won't even recognize scripts at all. It'll only see scenes. I have my sample scene, but I never want to leave my sample scene. Let's just rename it to main, right? And that's what I have so far. Let's add a simple cube to the scene because this is just an example that we're going to use for our for what we're doing. So I'm going to add in two things. I'm going to add a plane to the scene. There's my plane. And on top of that plane, we'll call this the ground. Ground. And on top of this, we're also going to add in a cube, or there's a cube. And what I want is for the cube to be elevated on like higher up on the ground. And in Unity, Y is up, whereas in Unreal and also in Blender, Z is up. So I want to, if I move this to 1, you can see it's too much. But if I go to 0.5, you can see that now my cube is kind of sitting on top of this thing here, this ground, right? And we'll make the cube into, we call a player. There we go, player. And let's add some materials. So again, in here, I'm just going to add in some dummy materials, a folder called materials. And inside my materials folder, let's add in something called the player material. This is the player material. And the player material will make it green, right? Again, this is all something that you should know how to do. It should be reviewed for you. You've probably done Unity to death. I'm going to take this player material and drag and drop it onto the cube just to make it a little bit more interesting. And the ground material, let's make another one, a new ground material. So we'll say a new material. We'll call this the ground material. Ground material. And we're not immediately going to add in anything like this, but in fact, what I want is to create a folder called textures. And I'm going to give you a texture that you're going to put onto it in a second. Let me just go in textures here and I'll give it to you. So where was that? I'm just going to go into my other folder here that I was using yesterday and grab that texture. So here's maybe not that one. Just give me 1 second here and we'll do it. I did lose somebody. I don't know who it was, but I'm hoping that you guys are good. And do I have a texture that's here or is it somewhere else? Or do I have to download it? I may have to download a texture, right? Do I have Blender models here? No. Let's go and do it. So up online, I'm going to grab something from textures.com and let's just grab a gravel cobble texture. You don't have to do this. I'll give you the texture online. So I'm going to go to ground, gravel, gravel cobble, and I'm going to grab a gravel cobble texture that looks like this. No, maybe that looks like this. Sure. Okay, that's better. And I'm going to grab that texture. We'll call it gravel cobble. I'll put it in my downloads folder. Downloads. And we'll put that in there. So it'll be gravel cobble. Gravel cobble texture. And for now, the great thing about Zoom is I can give it to you. So I can just go like this and just populate it inside of your chat. It's there. I've just given you the gravel cobble texture. Online, I'm just going to put this inside of the in-class exercise requirements. So I'm going to put that in here. It's going to populate that in there, gravel cobble texture, right, for the in-class exercise, right? And what I want you to do here is I want you to change the material that we're using for the ground. So if I go to ground material, and I want you to populate the albedo with the gravel cobble texture. We don't have textures. Let's add that in. So the gravel cobble texture is going to be in the downloads folder for me. There it is. And we're just going to populate that in there. I'm just going to drag and drop it into Unity. And I'm just going to take this gravel cobble texture and pull it into the albedo channel. Albedo, albedo, tomato, right? And that's what the ground is going to be. So the ground material is going to have this gravel cobble texture. I'm going to take this ground material now and, and pull it onto the ground like this. And you can see that there's a ground material, but it's too big. The gravel cobble texture looks like really massive. What we can do here is from a tiling perspective, let's change the tiling to 4 and 4 like this. So you can see that the gravel cobble texture looks like, well, cobblestones, right? That is your Unity scene. And I've contrived reasons for doing this for you. Why? Because now we have a few folders of some stuff to put up on GitHub, right? And this is going to be our starting scene for next time. When we do that, we do our stuff next time. So I'm going to file, save. I'm going to file, save project, right? And I'm going to leave Unity as is. Let's leave Unity. Now I have my project. And if I go to my desktop, you can see that I have my project inside of here, but I don't want to put my gitignore in my containing folder, not here. I want to put my gitignore inside of my in-class exercise. That's in here. Guys, I know that I'm going over time, and if you got to go, I'll keep recording, okay? So here, what I need to do is I'm going to put in my new, I'm going to put a new text document. This is my new text document, which I'm just going to rename as .gitignore. Again, it's inside of the in-class exercise folder. Here's my .gitignore. It's right now, it's empty. I'm going to double click onto it and I'm going to open it up in my favorite editor or notepad. And I'm going to go back to where I had that gitignore, thing that I had up online here. Remember I had that Unity gitignore thing? There it is. I want to grab all of this stuff and I can just click on raw here. I've searched for Unity gitignore and I got this, and then I'm going to click on raw. And then what I'm going to do is I'm going to grab all of this, right? All of this stuff, and I'm going to copy it and put it inside of my notepad right here, right? There it is. And then I'm going to save it. That is my Unity gitignore file. And instead of you creating it, I'm just going to give it to you. So again, here's my Unity gitignore. I'm going to put that in the chat for people who are still here. And I'm also going to populate it up on here. Okay, so inside of in-class exercise, I'm going to grab that Unity gitignore file and I'm going to populate it right here. Okay, so we're going to say that that's the Unity. It doesn't like that. Let's make a new file, a new link, a new file. I think it's a new file. Wow, I didn't know that. at least for Canada, or doesn't like it. And we'll say this will be called Unity git ignore. It works everywhere else. And how do I add a file? I don't even know how to do that here with this. Anyway, so I'll put this up, a Unity git ignore file, which is what I need to do. The reason why it's not accepting is because it is .git ignore, and it can't be a .git ignore, but that is what you need. And all it is like I said, I just went and copied this stuff from my notepad and put it in there, right? Anyway, you'll be able to get it from me if when I put this up on GitHub, you'll have my GitHub repository in a second, okay? So now that I have my Unity git ignore file inside of my project, I want to navigate with my command prompt to where it is. So back to my file system, right? I want to navigate here to my in-class exercises, right? This is where I want to go. So the containing folder. So I'm going to say CD, which stands for change directory, pull this over, right? And then I'm going to press enter. And then I'm going to do my git init. So this is my first command, git init, right? And if you notice what it does is it created inside of this file a hidden .git folder at this level above all the other in-class exercises. It's in the main master folder, all right? Not inside of here, not in here, right? And then what I need to do is I'm going to add the next part, the next command, git add dot. This adds all my stuff to the repository, but it ignores my scripts folder because it's empty, and it ignores my library folder because that's what's in the git ignore file, okay? So git add dot. The last command is git commit -m, and I'm gonna call it initial commit. And that's gonna be the way I take a snapshot of my files, all right? So that's what this did. Same thing that we did last time, but with a pile more files than we had before, okay? And now that we have this, we need to connect this to our remote. And we have a remote. I'm just going to go here and go back to my remote. Here's my remote. And this is my new repository for my in-class exercise ICEs, right? I'm going to copy these last 3 lines of code here, right, to connect my remote. And this is a one-time deal. You never have to do this again if you do it my way. Copy it, and then go back to your command prompt. And if you need to, you can copy it manually yourself, or right-click and then press enter. And if you did the last little exercise together, this is a no-brainer. This works just fine, okay? So then if I go here and refresh, you're going to see that I've got my first in-class exercise. That is all I need you to do. There's a single commit right now, and that's okay for this exercise. I like to see this as a freebie. It's kind of really easy to do. If I look in there, you'll see my Unity project with no library folder, okay? So that's what it's going to be inside here. All right, and that is the in-class exercise. It's really quite simple. It's a setup more than anything else. And this is now my new repository. If you look there, you'll be able to see it as well. Check. Okay. After this, after class is done, I'm going to go into my little lab report, and I'm going to update these details. Make a little project, add a cube and a plane, take the texture, put it over. All these things I'm going to put in here, right? Just like the stuff we just did. And then I'm going to ask you to do the exact same thing that I did, okay? And when I do that, you'll have all these details here for you. Just follow these things and check mark. In other words, like highlight the ones that you could complete. Remember, for you to view your in-class exercise, you need the lab report, a short video, and the link to your GitHub repository, a working GitHub repository that has stuff in it. If it's empty, not accessible, if it's not named properly, all those things will either lose marks or you'll get 0, okay? 4%, it's worthwhile watching the video and making sure you get this right, okay? Questions before we stop for the day? And I'm sorry that we went a little bit over time. Okay, if there's no questions, I'm going to stop recording here and I'll take any questions after class. In terms of assignment, one more thing before we go. The assignment I will post with all the details. I mentioned that there's a couple things that are happening today in our schedule. And one thing is that there will be an assignment that I'm going to be releasing today. The assignment is going to be due in 2 weeks from now, and it'll be something to do with what we're doing here, clearly with something like arrays and lists and maybe even a sorting algorithm. It might be something like that the assignment has. Again, it'll be due 2 short weeks from now on the Sunday of week 5. Okay. That's it for me, guys. Look forward for that. And I might send a little note saying, hey, the assignment's been updated. Please check it out and blah, blah, blah. That's it for me, guys. Thank you so much. I'll stop recording.